Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. This lecture covers the measures of relative position, the z-score, the box plot, and outlines. So our main objective is to determine the quartiles of a data set. We're also going to determine the interquartile range of a data set, create a box-and-whisker plot, and also we are going to interpret other factors such as percentiles. Then we determine and interpret the standard score, which is the z-score. So we start with the factors. Here we say factors are numbers that partition or divide an other data set into equal parts. So a quartile will be a factors, which is divided into 4. Again, factors are numbers that partition or divide an other data set into equal parts. So quartiles is approximately divided an other data set into 4 equal parts. We have the first quartile, which is Q1, and this will be about 1/4 of the data fall on or below Q1. Then we have the second quartile, which is the Q2, about 1/2 of the data fall on or below Q2, which also we call the media. Now, to find the media from our previous lectures of a data set, first we put the values in order. Then we take the middle values. If the number of values are even number, then we take 2 middle values and find the average. So the same concept, if we are going to look for Q2, first thing we have to put all the values in order. So the concept of Q2 and media is the same. We also have the third quartile, which is Q3. This is about 3/4 of the data fall on or below, again, Q3. Next, we're going to learn how to find a p-th percentile. A p-th percentile is very important. It will lead us, for example, if they say we should find the 10th percentile of a value, then we need to find the location. Then we find the value in that 10th percentile. So a percentile is if a given set of data, let's say S1 to Sn, the p-th percentile is the value, say X, such that approximately the p% of the data is less than or equal to the X, and approximately 100 minus p% of the data set is greater than or equal to X. Again, we're going to see an example soon. So the next thing is, how do we find the p percentile? Now, to determine the p percentile, first of all, we form an ordered array by placing the data in order from smallest to largest, which means the first thing we need to do is to put the values in order, sorting it and ascending order from smallest to the largest. Then we find the location of the p-th percentile in the ordered array. And the formula to find the location is n times p divided by 100. Again, n is the number of values we have in the data set. P will be the percentile, again, divided by 100. Now, when n is the number of observation in the order data, as we said, and also if L is not an integer, which means it's a decimal value, then we need to run L up to the next greatest integer. So for example, if L is 7.1, we are going to run it to 8. The same thing if L is 7.9, we are going to run it to 8. Then we find the data value in that L location. Now, if it's an integer value, then we need to find average the data value in L location with data value in the L+1 location. So this means we have to take the 2 middle values and find the average of it. So let's see an example in the next slide. Now here they say we should be very cautious about the range. It's very important to remember that when you find the value of L, this result is not the percentile. It is the location of the percentile in the ordered array. So let's see this example. Here they say we should find the 50th percentile for the following data on the number of spelling errors found on 7 pages of a website. So these are the 7 data sets given to us. The first thing we can do, again, n equal to 7. We are looking for 50 percentile. So P is 50 divided by 100. So we can find the location first. So here we say n is 7. P is 50. So location will be 7 times 50 divided by 100. That gives us 3.5. So we approximate L to 4. Since the location of percentile is not an integer, the value is rounded up to 4. Then here we say the fourth observation, the ordered array is the 50th percentile. So the next thing, we are going to put the 7 values in an increasing order. So it will be 0, 1, 2, 3, 5, 7, 9. The fourth value will be 3. So this means our fourth observation is the 50th percentile, which is also the median value. Let's try another example. Here we say, suppose that 40 members of your company are given a screening test for a new position. These scores are reported in the table on the next slide. Now, to inform potential employees of their screening test performance, you may wish to report various percentile for the test score. Now, our objective here is to find the 10th and also the 88th percentiles for the test. So this is our test score on the left side, the table, and there are again 40 values. And we put them in order. On the right table is the same values, but they are in order, increasing order vertically. So from 18, 21, 21, 27, all the way to 82. The minimum value is 18. The maximum value is 82. So the next thing we need to do is to find the location. Now we know what's the value of n. N will be 40 since we have 40 items. And we want to find the 10th percentile first. So P will give us 10. So with this, we can find the location. Location will be 40 times 10 divided by 100. And that gives us 4. Now, since the L is an integer, we are going to take, again, L is 4. So we are going to take L and L plus 1. So we are going to take the 4th and the 5th observation in the array. Then we find the average of them. Now, since the 4th data is 27, the 5th data is 29, then we find the average of 27 plus 29 divided by 2, and that gives us 28. Now, we can go back to the table to make sure we have what we are trying to say. Again, the data is, the right table is in order now, from lowest to highest. So 18 is 1, 21, 2, another 21, 3. Our 4th value is 27, 5th value is 29. So we take, since again, L is 27, L value is 27 and L plus 1 is 29. We find the average of the two. Again, L was 4. So L plus 1 will be 5. And so that is the average, and that gives us 28. Now, to determine the 88th percentile is the same steps again. So first, we are going to calculate the location. This time, our P is 88. So L equal to 40 times 88 over 100, and that gives us 35.2. So we know if the L value is an integer, we take the L and L plus 1, the two values, to find the average. This time we can see the L value is a decimal value. So we are going to approximate it to 36. So here we say, since the location is not an integer, its value is rounded up to 36. So the 36 observation in the order array will correspond to the 88th percentile. So here they say the 36 value in the table is 73. So if that's the case, then 73 is the 88th percentile. Again, let's look at the table. Since it's 37, I will read down. So we can see here, this is 40. So at 73, 77 will be our 37, 38, 39, 40. So again, that's why our result again is 70. So that's the 36 value in the table is 73. So 73 is the 88th percentile. We can go back one more time. 36 is 73, 37, 77, 38, 39, 40, last value is 82. So the answer 36 will give us again 77. So next we have the formula for a percentile. We say the percentile of a some data value S is given by the following. The number of data values less than or equal to X divided by the total number of data values multiplied by 100. Again, the answer will be in percentile. Our previous examples, they gave us the percentile value and we have to find the value that is in that percentile. Now, they may give us the value and we have to find the percentile of the value. So to find a percentile of a value, let's say the value is X, then it will be the number of data values less than or equal to X. We have to count all the value that is less than or equal to us. First, again, we have to put the values in an increasing order before we count. Then we divide by the total number of data value, which is N, then multiply by 100. So here we have a definition. In this case, we're going to look for quarters. So we know if we are looking for quarters, it will be 3, Q1, Q2, and Q3. Q1 means 25th percentile. Q2 means 50th percentile. Q3 means 75th percentile. Now, to find interquartile range, it's always Q3 minus Q1. So here we say the interquartile range is a measure of dispersion which describes the range of the middle 50% of the data and is calculated as Q3 minus Q1. So this gives us the variation, the measure of variation, which describes the range of the middle 50% of the data or the values. Now, this is very important. We normally use this also to organize or basically to describe our data. A 5-number summary. The 5-number summary can lead us to graph what we call the box plot or box-and-whisker plot. So for a set of data given, the 5-number summary consists of the following 5 values. What is the minimum value? What is the maximum value? What is Q1, Q2, and Q3? Again, minimum value means the lowest value in the data set, maximum the highest value. Then we can find the 25% Q1, Q2, and Q3. So let's see example, and that will lead us again to the box plot. So box plot are a graphical summary of the central tendency, also the spread and the skewness. When we plot a box plot, we can see the spread of the data set from the center, and also if there's any skewness, we can see it. And the potential existence of outlines. Normally the outlines will be either below Q1 or above Q3. So this example, we have Q1 is 42, Q2 is 54, Q3 is 65, the maximum value is 82, the minimum value is 18. Now the outline, the minimum will be below 18. The maximum outline, the largest outline will be above 82. So in the previous figure, we saw the line is drawn from 25th percentile, and that's the boss. The smallest test score was 18. And then another line is drawn from 75 percentile to the largest, which is 82. So let's see an example. Now, to determine the 5-number summary for the data set, first thing we need to do is draw a scale that includes the minimum and the maximum data values. Then we need to find the Q1, Q2, and Q3. Then we can construct a box extending from Q1 to Q3. Then we draw a line in the box which is corresponding to Q2 or the median. Now, detecting outlines, we said different technology may yield different box plots due to differences in the procedure used for determining the quartiles. But again, the outlines we said always value below the minimum or above the minimum. So a data point is considered an outline if it is 1.5 times the interquartile range above the 75 percentile, or 1.5 times the interquartile range below the 25 percentile. So let's see example now. Here we say education attainment seems to have a positive association with a person's income. The amount of education a person has can be divided into 5 categories. So either less than a high school diploma, or it's a high school graduate, no college, or some college or associate degree. Then we have bachelor degree, or we have advanced degree. So in 5 categories. Now the categories are ordered according to educational attainment. So we have the vertical box plot in the figure on the next slide will show the distribution of a personal income per each level of education. Now for individuals age 25 and older, rather than extending the whiskers to the smallest and largest income values in each category, the whisker endpoint represents again the 10th and the 90th percentile. What conclusion can we be drawn from this? Let's see the figure. So we can see the first figure, less than a high school diploma. And we can see high school almost increasing. And here we can see the maximum values are increasing. Also at the same time, the minimum values also are increasing. So the conclusion we can draw from this graph here, we can say as the education attainment increases, also the weekly earnings also increase based on, again, the whiskey plot. So here we say it is rather obvious from this figure that more education equates to higher earnings. Also, there's a lot of spread in the last 2 box plots as shown by the longer lengths of the boxes. This may be probably due to the path to the market demand for degrees in scientific disciplines, especially again can be computer science, etc. Now, the next thing we're going to learn is what is a z-score. A z-score normally will transform a data value into the number of standard deviation that the value is from the mean. So z-score will be x minus mu over standard deviation. If we are looking for z-score, S will be our value. We subtract from the population mean, we divide by the standard deviation. So suppose your score an 86 on the biology test, and then 94 on your psychologist test. The mean and standard deviation for the 2 tests are given in the following table. So we know the mean is 74. Standard deviation is 10 for biology. Psychology is 82 and 11. Now, based on the mean score of the whole test and the standard deviation of the whole test, we can determine whether the student did good in biology or psychology. Sometimes even psychology score is 94. Biology is 86, but maybe due to the mean and the standard deviation, the z-score can tell us that the student did better in, again, biology with 86 score than psychology with 94, because everything depends on the mean. The mean means if the mean is high, it means majority of the students did very good. If the mean is very low, majority of the students didn't do good. So that's the whole idea of a z-score. Now the question is, what are the z-score for your 2 tests? Now, on which of the tests did you perform relative bearer? Everything depends on the z-value. So the first z-score for the biology, 86 minus 74 divided by 10. Why? Because 74 is the average, 10 is the standard deviation. So that gives us 1.2. The next score we can see, the student if score high, 94, but the z-score is 1.09 because of the mean is higher, which means many students did good. So this will tell us that on the biologist test, you score 1.2 standard deviation above the mean, comparing to only 1.09 standard deviation above the mean for psychology. So this means scoring 86 is better than scoring 94 in psychology. So that's what we say here. Even though the raw score on the psychology test is larger than the raw score on the biology test, but relative to the means and also the variability in the data set, the performance on the biology test was slightly better. Again, once again, changing the scale of the data has beneficial effects. And also it enables the comparison of two measurements that are drawn from different populations. So again, this score always will tell us how better we do based on the average and the standard deviation of all the data sets. So the property of a z-score is, if a z-score is negative, then the corresponding data value is less than the mean. Now, if the z-score is positive, it means the corresponding data value is greater than the mean. And also the z-score is a unit-free measure. That is, regardless of the original unit of measurement, either centimeters, meters, kilometers, an observation z-score will be the same. So that will be the conclusion of these lectures. Again, in these lectures, we focus on the concept of measurements of relative positions. When we say relative positions, we mean the Q1, Q2, Q3. We also went through the concept of percentile, z-score, what is a box plot, and also outlines. So again, wish everybody the best and see you in the next lectures.